Okay, so a couple of questions from section 4.2. Strangely enough, very much like our assignment, but whatever. Question number 20. So Wayne has a briefcase with a 3-digit combination lock. He can set the combination himself. His favorite digits are 3, 4, 5, 6, and 7. So that's what he's going to be using, those 5 elements. And he's going to be arranging them in a combination, which has a position for it. So the first question is, how many permutations of 3 of these 5 digits are there? So we'll go over to the board. I've got a little bit already set up here. So again, we've got available digits of 3, 4, 5, 6, 7. 3-digit code. Okay, and it's a code or combo, so it's going to be 1, 2, 3 positions. So you notice I've drawn out positions here. And each digit can only be used once, so the elements disappear as we go along. Okay, so first things first, we've got 3 elements and 3 positions. Sorry, we've got 5 elements and 3 positions. How many 3-digit codes can we make? Well, if we fill in the first code first, then there's 5 numbers that we can put in that particular position. Okay, 3, 4, 5, 6, and 7. There's 4 numbers after we use one of them up, okay, in here, and then 3 numbers after we use another one of them up, okay, leaving us with 5 times 4 times 3, or 60 different codes. Okay, how many can be odd? Well, when we have specific cases, we use, or conditions, odd, then we use cases or we use fixed values. So in this case, for a number to be odd, if this is a number, for a number to be odd, the number of ways that are possible are going to, doesn't matter what's in this spot, doesn't matter what's in this spot. This has to be an odd number. So we've got the number 3, the number 5, and the number 7. Those are my odd numbers. So I could have 3 or 5 or 7 in this case. So there's 3 numbers I could have in there. You can do them separately. Fix a 3 in here and put a 1. Fix a 5 in here, put a 1. And fix a 7 in here, put a 1. But really it's 3 that are identical. In that particular case then, in all the other positions, we can have any numbers, whether they're odd or even in this case. So once we use up the one number to fill up this specific spot or condition, then we fill up the rest of them. And so we're going to have 4 numbers that are left because we used 1 here. And then 3 numbers that are left from that. So 4 times 3 times 3, which is 4 times 3 times 3 is 36. Okay? How many of those situations can be even? Okay, so it's going to end in an even number. We only have 2 of those, 4 and 6. Okay, but begin with a 4. Okay, so in this case, it has to have a 4 in this particular spot, which means there's only one number that could go there, the number 4. If that's the case, then the only even number that we have have the 6 and the 4 to make this even. The only thing we have left is the 6. So there's only one number that could go in there. And then there's only 3 numbers that are left. We filled here, we filled here. There's 3 elements that are left. Basically the 3, the 5, and the 7. Okay, so we have 456, 436, and 476. Okay, again, we multiply all these, and we get 3 possibilities. Very, very narrow for that one. For this last one, for part D, last calculation we have to do at least, it's got to be even, but we don't want a 4, so in the front. So this is going to be even. We can put the 4 there, but we're not going to have the 4 there. Okay, so this can be anything but the 4. So the first thing we're going to do is we're going to fill in 2 different cases. Okay, the reason why we're going to fill in 2 different cases is because that 4 is a bit pesky. Okay, so if we put the 4 in this spot, it could only be the 4. We could also consequentially have the 6 in this spot, which could only be the 6. Okay, now it has to begin with not a 4. Okay, so if I put the 4 here, then that means that there's going to be basically 4 other numbers that I can use. And then 3. For here, if it ends with a 6 to be even, okay, I don't have 4 numbers for this spot. If I had 4 numbers for this spot, I would be able to use not the 6, so it would be 3, 4, 5, 7, but the 4 can't go here. So I fill it in with the 3 and the 5 and the 7 in that spot. Okay, and then I actually have one number here, so I've got 3 numbers left. Multiplying all these together, I kind of ran out of room here. So this is going to be 12. Yeah, I know, I'm forgetting where to draw it. This is going to be 12. This is going to be 9. And because it's either this situation or this situation, we add them up and we get 21. Now, how do these all connect together? Because that's what E is asking. Well, if you notice, this is all the possibilities. This is all the things that we can get. these are all the odds, which should be kind of half, but it's a little bit more than half because you have more odds than you do have evens. Okay? So these are all of the odds. And I'll circle that in blue. Now, if you look at it carefully, this is even begins with a 4. This is even not begins with a 4. So that means that these guys are all the evens. All the evens are in the red. All the odds are in the blue. And then, of course, everything is in the green. So 21 for not beginning with a 4. 3 for beginning with a 4. 24. Evens. 36.